So now in this chapter we are going to learn about mole. So what is a mole? Just like a dozen is 12, a mole is 6.022 10 to the power of 23. So if somebody says 1 mole of atoms, that means we have 6.022 10 to the power of 23 atoms. And you should also know that mass of 1 mole of an element is its atomic mass. And 1 mole of a molecule means it will have 6.022 10 to the power of 23 molecules. And mass of 1 mole of a molecule is the molar mass. So remember these two facts. 1 mole of an element's mass is atomic mass and 1 mole of a molecule's mass is molar mass. And the volume of 1 mole of a substance is 22.4 liters at STP. And the relation between mole and molar mass is mole equals gram over molar mass. So whatever we have given in this slide is important to do various questions on moles. Calculate the mass of one atom of potassium and the atomic mass of potassium is given. So in order to do these questions, so we know that 1 mole of atom equals 6.022 10 to the power of 23 atoms. And mass of 1 mole of an element is its atomic mass. So in these kind of questions always starts with what is given. So you have asked to calculate the mass of one atom of potassium. So mass of one atom of potassium. So let's see how many atoms are there in 1 mole. So the first step is 1 mole has 6.022 10 to the power of 23 atoms. And in order to convert it into grams, multiplied by the mass of 1 mole of potassium, that is 39.099 grams. And you could see that the moles gets cancelled and the answer comes as in the unit of grams per atom. So 6.49 10 to the power of negative 23 is the mass of one atom of potassium. How many atoms are there in 0.85 moles of iron? A simple question. We know that 1 mole has 6.022 10 to the power of 23 atoms. So start with what is given. We write down 0.85 moles first, and I need to cancel the unit of mole and get the answer in atoms. Therefore multiply it by Avogadro number 6.022 10 to the power of 23, and which is present in 1 mole. Therefore the moles will get cancelled. The answer will come in the unit of atom. Another question. How many moles are there in 4.28 10 to the power of 28 atoms of carbon? This is the reverse question of what we did before. So as I say, when I keep saying is, if any number is given, write down that first. The number given in this case is 4.28 10 to the power of 28 atoms. Then you look, they have asked you the answer in moles. Therefore I have to convert the atoms into moles. So therefore multiply in such a way that the atoms gets cancelled. Therefore 1 mole will be at the top and 6.022 10 to the power of 23 atoms will be at the denominator. The atoms will get cancelled and the answer will be the number of moles present in so many number of atoms. Calculate the number of moles and atoms in 27.52 grams of zinc, and the average atomic mass of zinc is given. So as usual, start with any number which is given. So write down the first number which is given over there, that is 27.52 grams. And I have to calculate the number of moles. That means I have to get rid of that moles. And we also know that 1 mole weighs 65.38 grams. Therefore, if I multiply it in such a way that the grams gets cancelled, I will get the moles of zinc. And therefore, I am multiplying by 1 mole divided by 65.38 grams. And the moles of zinc comes as 0.42. But the question is asking the number of atoms also. So to get the atoms of zinc, I have the number of moles, and you know 1 mole has 6.022 10 to the power of 23 atoms, and therefore the number of atoms of zinc will be 0.42 times the Avogadro number. Find the number of moles and atoms in 38.2 liters of oxygen at STP. So we use the formula 1 mole at STP occupies 22.4 liters. So So divided by 22.4 liters, I get the moles of oxygen. So now once I get the moles of oxygen, I can get the atoms of oxygen by multiplying it by the Avogadro number. So basically you need to remember the formula given in the beginning of the slides. What is a mole, and what is the mass of a mole, and what is the mass of a molecule, and the volume of a mole. Find the volume of 86.2 grams of nitrogen gas at STP. Atomic mass of nitrogen is given, and you know that 1 mole of any gas occupies a volume of 22.4 liters at STP. So the first we will convert the grams to moles, then using the moles we can get the volume. So that's what we have done. I've converted the 86.2 grams into moles by dividing it by the molar mass. See that nitrogen exists as N2, therefore the molar mass is 28.02. Then when you times it by the volume occupied by 1 mole, I get the volume of nitrogen for 86.2 grams of nitrogen. Find the atomic mass of the element that has 1.38 times 10 to the power of 23 atoms in 12.5 grams. So in this case, number of atoms is given, grams is given. So our first step is to calculate the number of moles. Then we will use mole equals gram over molar mass to calculate the atomic mass. See, it will be molar mass if it is a molecule. Since it's an element, it will be atomic mass. So when you calculate the moles, I will use the number of atoms given, and you know that in 1 mole I have Avogadro number of atoms. So divided by the Avogadro number to get the number of moles. Then once we get the moles, use the formula. A mole equals gram over molar mass, and I get the molar mass as 54.82 grams per mole. Since this is an element, this is the atomic mass, and when you look at the periodic table, I realize that this element is manganese.